So for the third problem, I first find the summation of x, which is equals to 0. So since the t1 is on the left side of the Cartesian plane, I put negative t1 cos 15, since it should be cosine since the triangle is here and the theta is here. It is the opposite, adjacent, and the hypotenuse. So to find the x, it should be adjacent over the hypotenuse. So t1, negative t1 cos 15 degrees plus t2 cos 30, since it is the same as well with the t1. So it should be cos 30 degrees equals 0. Then transpose the negative t1 cos 15 degrees to the right side. So it should be like this. Then manipulate the equation for you to find the t1. Then divide both sides by cos 15. And the equation would be t2 cos 30 degrees over cos 15 degrees is equals to t1. So t2 cos 30 degrees divided by cos 15 degrees is equals to t2 0.9 equals to t1. So that will be the equation for the t1. 0.9 multiplied by t2 is equals to t1. So for the summation of y, it is 0, 2. To find the summation of y, you should sum the positive forces and the opposite forces, and it should be equal to 0. So t2 sine 30 degrees plus t1 sine 15 degrees minus 9.8 meter per second squared, and the mass of 7 kilogram is equal to 0. Then transpose the negative 9.8 and the 7 kilogram to the right, and the answer would be 68.6 n. So here's the equation now. t2 sine 30 degrees plus 0.90 t2 sine 15 degrees equals to 68.6 n. And t2 sine 30 would be 0.5 t2 plus 0.92 multiplied by sine 15 is equals to 0.23 t2 is equals to 68.6 n. Then add these two, the answer would be 0.73 t2 is equals to 68.6 n. And divide this whole thing into 0.73, and the t2 now would be 93.97 n. So for you to find the t1, you should substitute this t2 from the equation. So 0.9 multiplied by 93.97 n, and the answer of t1 would be 84.57 Newton.